Okay, welcome to the regression analysis session. So, this is the third week of the lecture. So, last week we have covered binary and multi-class classification. So, today we will cover regression analysis. So, let me recall back what we have studied last week briefly. So, this is the concept that we study last week, in which we look into the type of machine learning. So we have supervised, unsupervised, and reinforced learning. In supervised machine learning, we have categorized them into two, which are regression and classification. So basically, we are looking into two categories. But last week we cover binary and multi-class classification, the theory of binary and also multi-class classification. We have not looked into the algorithm yet. We just look at the foundation of binary and multi-class classification. Okay, so the difference between regression and classification is that for regression technique, we use this one to predict the target values of continuous variable, which means that they are used to predict continuous variables. But it could also be used for categorical values. We will look into that one. But for classification, they are mainly used for class label. Okay, we cannot use classification for predicting continuous variable. Okay, so today we will look into regression analysis. Okay, what are they, and then how many type of them, and how can we use them to perform prediction. Okay, so this is the overview of the regression analysis. First, we will look into the regression analysis. What is regression analysis? And then we will look into the type of regression analysis in which we have simple and multiple linear regression. And we also look at the how do we interpret the result, what assumption that we make, and then what is dummy variable in linear regression. And there are two other more regression called logistic regression and regression tree. So this one we will cover in the next lecture. Okay. Okay. Regression analysis can be used to measure the influence of one or more variable on another variable. So in this case, we have the qualification, the amount of time spent, and also the age of the person can be used to determine what is the salary of that person. Okay. We can use regression to measure the influence of one or more variable on another variable. So this is called independent variable predictor because they are used to predict your dependent variable. Okay. So this is the amount of salary lah. Okay. And this is the same like we perform the prediction of the salary based on one variable or more than two variables. Okay. So the other example is when we talk about measurement of the influence of one or more variables on another variable. One of the example is that what influence children ability to concentrate. Okay, so the dependent variable is concentration, ability to concentrate. Okay, and the independent variable could be other factor. Another example is do parent educational level and place of residence affect children's future educational attainment? So this is your dependent variable, and these two will be your independent variable, the education level and also place of residence. Okay? So this is your IV, this is your DV. Okay? So we can use regression analysis to measure the influence of one or more variables on another variable. So this is your independent variable, this is your dependent variable. Always remember that. Okay, and regression analysis can also be used to predict the value of variable by one or more and other variable. So these are the two um, functions that can be done for uh, regression analysis. For example, like this, we can predict how long a patient stay in a hospital. So the dependent variable here is the time. Okay, and then this one, what product is a person most likely to buy from an online store? So this is your dependent variable. So notice that this is not continuous value. This is a categorical value. This is continuous value. So like I mentioned just now, regression analysis can be used to predict for a continuous value and also for categorical value. Okay, we will look into that one in depth. Okay, so what form of regression analysis can we have? We could have simple linear regression in which we have one-to-one. So this one is the uh, amount of qualification that influence the salary. We could also have the amount of time spent and whether that influence the salary that we have and also the age. So simple linear regression only dealing with one dependent variable and one independent variable. Okay, we could also have multiple linear regression in which we have more than one independent variable that are used to predict the dependent variable. Okay, so in this case, this is money. So money is a numerical value or continuous value or matrix. Okay, continuous value. Okay, and there is another one called logistic regression in which we are trying to classify. So this is based on three independent variables. So this one is whether the person is happy or not, or we can also say whether the person is stressed or not, or whether the person overworked or not. Okay, so yes and no, yes and no. Okay, so meaning that we have 0 and 1. Okay, so we will look for this session, we will look into this two only. And the next session, we will focus on this. And notice that all this value could be matrix or continuous value or numerical value, ordinal, nominal. This is label or categorical value. So the ordinal we have um, ranking like poor, average, good, excellent. So that is ordinal. They have ranking. Nominal, they do not have ranking. For example, male and female, bi or not bi. Okay, okay. Like I mentioned just now, for simple linear regression and multiple linear regression, we try to predict a variable of type continuous value or matrix or numerical values. And compared to logistic regression, oh, are you still with me? If you're still with me, can you type number one? Okay. So the third one is logistic regression, in which we use the nominal or ordinal variable um, as the dependent variable. Okay, so we will look into that one later on. Okay, for the categorical variables, we we could have two variables, or when we have three unique categorical values, so we need to change them into dummy variable. Okay, so we look into this one also. So this is only for logistic, no, for um, when you want to predict categorical value. Okay, okay, for the simple linear regression. Okay, now we are focusing on the simple linear regression. Whenever we have this diagram, does the weekly working time have an influence on the hourly salary of the employee? Voice not clear. Now it's okay. Can you hear me? Can you hear me now? Okay. So for the multiple linear regression, we have two independent variable. So for example, this one we are looking at, do the weekly working hours and the age of employee have an influence on their hourly salary? Can you hear me? Boleh bahkan? Boleh. Okay, boleh. Okay, if you are with me, can you type number 2? Okay, so let's continue. Okay, for this one, so for simple linear regression, we have one independent variable, and for multiple, we have one or more than one. Okay, okay, for the simple linear regression, we should have two variables. So, for example, like this, for the independent variable, we have the age, and then we are saying that the age has influence on the length of stay after surgery. Okay, so this is your dependent variable. This is your independent variable. Okay, so what we want to do is we want to draw a line here that will relate these two values from two variables. So from the line we can have a formula. So in which we have the dependent variable here and the independent variable for this one. And A is the intersection of y when x is 0. And B is the slope. Okay. So based on this diagram, we have this. So in which when we have x is 0, so the intersection is 1.2 here. Okay. So we can plug in any value for the x for the age, then we can estimate the number of the number of days that they stay after surgery. Okay. And for example, if we have 33 years, no, yeah, 33 years of age, then we have 5.82 um, number of days that they stay. Okay. And how do we calculate A and B? So B can be calculated based on the correlation between this value, age and the length of stay, times the standard deviation of y divided by the standard deviation of x. Okay, and A, we can take the mean of the y minus b times the mean of x. But when you perform the linear regression, all this will be calculated for you. So what they will give you will be the formula. Okay, and this is the coefficient that they need to estimate. This one. Okay, and in trying to learn the data, we also want to know how much error that they make by finalizing the line. So the error here, the epsilon here is the error, the amount of error that we have for all the point to the predicted value. So this is your actual value, and this is your over here is your predicted value. Okay, so we wanted to find the error. So how do we find the error here? So for example, in this example, we have temperature and distress event. So we draw a line here to represent our data. Okay, and for this example, we have the alpha, which is the interception here, is 3.7, and the coefficient beta here is minus 0.048. Okay, so how do we measure the error? So we will get the actual value and then minus the predicted value, and then we square that one, and then we will do it for all the point that we have, and we sum up them. Okay, so this is what we call sum of square error. Okay, sum of square error. So based on this, we know how much true or how good is the line that we have drawn to represent our data. Okay, but in most cases for the linear regression, we are looking at the R square. So R square is the value that we use to know how good is the model that we get to represent our data. Okay. Okay. We when we looking at two variables, we also look at the correlation between two variables. They are defined as the number that indicate how closely they are related to each other. So the range of the correlation is between -1 to 1. So if 1 meaning that they are highly correlated, -1 they are highly correlated but in reverse order. Okay, so if they are 0, which means that there is no relationship between variable A and B. Okay, if you look at the one example for the correlation, we cannot use correlation as a measure of linearity of the data. Okay, in most cases, um, correlation, we have high correlation, but in fact, we do not have linear data. So, coba kita tengok this example. Okay, um, this command can be typed at the R square. So we will cover this one later on lah. So call up and explore the data. We get the data from this ANSCOM. And when we look at the structure of the data or the data that we have, so we have X1, okay, this one coupled with this and so on. Okay, and X2 coupled with this. So based on this data, if we measure the correlation between these four set of data, okay, so we use COR to determine the correlation between variable 1, X1, and Y1. So all of them give almost the same correlation. Okay, so based on this, can we assume that all of them has similar structure or similar relationship? Okay, so when we perform the plotting, we use this plot and then X, Y. Okay, so this is what we get. Okay, so plot number 1 appear to have a true linear relationship because we can draw a line here. Plot number 2 is curvilinear. So curvilinear, so this is not linear. Plot number 3 has a dangerous outlier. So although we have, we cannot draw a line here because of this one. This is outlier, similar to this. So plot 4 is driven by one outlier also here. Okay, so these two cannot be considered as linear problem, and this one, yes. So based on this, although all of them have similar correlation, but we can never say that they are linear. Okay, we cannot say that there is a linearity in the data unless if we plot them. So only by using graphic we can figure out or confirm that they are a linear problem or not. Okay. So now we all know that we can have independent variable and also dependent variable. So let's take a look at this example here. In the first example, we want to predict the water yield, like the amount of water of the Snake River in Wyoming, USA, as a function of the water content of the snowfall. So we have Y and X. Okay, so your X will be the water yield, amount of water in the Snake River, and your X will be your water content in the snowfall. So this is your water in the river, because when you have snow, all the snow will melt and then go into the water. So this is your independent variable, this is your dependent variable. Okay, so we have this data lah. Okay. So we get the data from Snake, and then when we print, we get this X and Y. Okay. Then for this one, since we have X and Y here, we want to change this name to um, content and yield. So we just use C here, combine, and then we get the content and yield here. So we just change the name. Okay. And this one will attach the name, new name, to the data that we have. So when we look at the first 6, we use the head here just to look at the first 6 row of our data. And if we plot, we will get this. Okay, so we can draw a line here lah. Okay, so how do we draw the line? First, before we draw a line, meaning that we want to perform a regression analysis, it means that we are going to draw a line here. So for us to be able to draw the line, we have to perform the linear regression analysis. Okay, so this is just a name, and this is your Y, this is your X. So we use this symbol to show that I want to model my yield based on the content of the snowfall. So this is your independent variable, this is your dependent variable. Okay, so we are using linear model here. Okay, so once you type this one, you are actually modeling the data, and we have one model. So this is the name of our model. So based on this, we are saying that okay, this is single linear regression. So we are looking at this one. So this is the R square that we have. We have significant values if we have p less than 0.05. Okay, so for this one, this is actually, wait, This is for this. This is for this. So as long as we have 1 star and above, okay, so we have 3 star here. So this is a very significant result in which the p-value is less than 0.05. Okay, so this is the p-value. Okay, and this is the the residual that we have. The maximum error that we could have will be this. The minimum will be this. Okay, so when we want to plot the line, we just plot content and yield, and then we are looking at this model. So this is the line of the model. Okay, so any question? So normally based on the result that we get, we look at this number here, the star here. The star here is that the content has a significant influence on the yield. Okay, because we have 3 star. So as long as you have star here, that means they have a significant influence. Okay. Any question? You still with me? P. Where is P? Where is P? Oh, P value. You're talking about P value. P value is when you perform the statistical analysis. We are referring to P value of the statistical analysis. This P value. Okay, so in the two-tail analysis for the statistics, we refer to the p-value. If the p-value is less than 0.05, meaning that they have significant effect on the formula changes lah. Okay. Okay. So this is for the linear regression. We will look into the multiple linear regression. So for the multiple linear regression, we have 2 or more um, independent variable. Okay. So for this one, instead of having one only, this is simple linear regression. So now we have many. So we have k number of variable. Okay. The coefficient are interpreted similarly to the linear regression equation. This is your coefficient. So they will be estimated to fit the line. Okay. If all the value of x1 up to xk are 0, so the value a is obtained. So this also have to be estimated. Okay. So for the multiple regression, the y will be your dependent variable, and the rest of x1, x2, and xi, they are all independent variable. And this is the error that we get. They are calculated using the same method in the linear regression. Okay, but how do we simplify this formula? Because we wanted to estimate the beta 1, beta 2, and beta I, and so on. So, and we also have this alpha. So in order to standardize this one, because this is constant, kan? So this is constant. So I can transform them into beta 0. Okay? And in order to standardize the formula here, I can add this one, x0. But x0 here, we can set them to become 1 because beta 0 times 1 is beta 0. Okay, so this one I just changed the name. Okay, so once we get this format, so we will have something like this. This is the coefficient that we want to estimate, and this is the variable of x0 up to xk. Okay, but for the x0, we set them to 1 constant because remember that the x0 here, so we just add this variable, but basically the value will be 1 because we want to have similar value here. Okay, so this is the simplified formula, so in which we have all the dependent variable here and your independent variable here. So what we want to do is we want to estimate these values. What are these values? Okay, so once we get this matrix, now this formula, condensed formulation, we can estimate the beta here by using this formula. So in which, because we know what is x, so we know what is this x matrix. We get all the value here. We also know what is this. Okay, so to estimate the beta here, so we just take the transpose of the x times x, and then take the inverse of this matrix, and then times x transpose times y. So this can be done in R, and this is the formula that we have, in which we take y and x because we have y and x. Okay, so when we take the x here, we transform them into matrix, and then we this one we take the inverse of no this one we take the transpose of x. Okay, so when we have so now what we want to do is we want to take the transpose of x and then times the x, which is this one, times transpose of x times y. So we have all this. Okay, so this one is basically trying to get the transpose, no, the inverse of this formulation. Okay, so if we are using R, we can perform this to estimate this one. But when we use the model, the multiple linear regression, we do not have to do this because it will be computed in the multiple linear regression formula. Okay. Okay. For the assumption for us to use linear regression is that there must exist linear relationship between the dependent and independent variable. So how do we know that? We have to perform the test using the graphic. Remember just now? Okay. So we can only know that there is linear relationship between the dependent and independent variable if we can draw a line that will represent all the data that we have. The second one is the error are normally distributed. So meaning that we have a normal distribution of the error. And the third one is no multi-collinearity or no instability of the regression coefficient. So this one, we have a way on how to check this one. And the fourth one is no heteroscedasticity, in which the variance of the residual must be constant across the predicted values. So there is a way on how we can check this one also. So we have 4 assumptions that must be met. Okay, the first one, there must be linearity. So this is not linear. The second one is we can use the quantile plot. So based on the quantile plot, all the values should fall near the line. So by having that, we are sure that they have normal distribution of the error. And this one also, the homoscedasticity, we have constant variance of the residual. So we have to have something like this, in which this is your mean, and we have the error scattered around the 0 line. Okay, and we do not want to have something like this. Okay, and then the last one is that we do not want to have a multi-collinearity. Okay, what is multi-collinearity? In a multi-collinearity, 2 or more of the predictor correlate strongly with each other. For example, if x1 and x2, they have high correlation with each other. So when we have high correlation with each other for these 2 variables, very hard for us to estimate B1 and B2. Okay, so your regression equation becomes unstable. Okay, so we do not want to have this. So how do we check? We can check for correlation between the independent variable that we use to predict the dependent variable here. Okay. So the next one is, let's take a look at when we have categorical variables with 2 characteristics. So for example, like this, let's suppose your x1 is categorical values. They are not continuous values. So we have 0 and 1 here, female and male. So we can divide them into female and male. So this is for 2 characteristic. Okay? So we can use this formula. But for the 3 variable, so for example, like this, we are looking at the consumption. No, we are looking at the horsepower and also the type of car here to determine the fuel consumption here. But our vehicle here, we have 3 types. Okay, so we need to convert them into dummy variables. So we have to create these 3, and then the value is 0 and 1. So if you want to indicate that they belong to sedan, we put 1, 0, 0. And sedan also, and sport car, we have 0, 1, 0. Okay. Okay. But this one can be reduced because if you look at that, we can delete this one. We only need 2 because this 2 is enough to represent these 3 variables. So for example, if we want sedan, for example like this, if you want to have a sedan, then 1. If you want to have a sport car, then we will have um, sport car. So if you want to have family, so that means the value must be 0, 0. Okay, so we can change this 3 variable with 2 characteristics each. So this is 2 variable. Okay, now we go into the practicality of using R. Okay, this is the example of one dataset that contain medical expenses for patient. So what we want to do is we want to predict how much they need to pay for the medical expenses or for the insurance. So they have the age. So this is numerical value. They have the sex, which is categorical value. They have BMI, numerical value. They have number of children. This is numerical value. Smoker, yes or no. This is categorical value. And region, categorical value. Okay. So for the smokers and region and also the sex, um, we will convert them into dummy variable. But this is done inside the uh, process. Okay. So you just need to apply them. Okay. So um, this is the step that we need to follow. So the first thing is that we read the data from the insurance, and we are saying that all the string character to be categorical values. So for example, like this is a string, but they are considered as categorical value, same thing as this and this. So we have three of them will be maintained as categorical values when we read the data into insurance. So when we look at the structure of the data, so we have 7 of them. So this is your dependent variable because we want to estimate the charges based on the 6 variable that we have here. Okay, so the 6 here are the independent variable. The charges will be your dependent variable. Okay, so if you look at the summary of your insurance charges, so the maximum value is 63,000 and the minimum is 1,122. And also, if you look at the histogram, many pay around here. Okay, so we have a declining trend here. We can use this histogram plot on the charges. Okay, and the first thing that we can do is we can look at the correlation between the metrics. Correlation between the variable. So we only can do this one for all the numerical values. So we take the age, BMI, children, and charges. Okay. So remember that when you have a high value of the correlation, that means they are highly correlated. Of course, this is one because we are looking at age and age. Okay. So the highest one, if we study, will be from this area. So the highest one is this one. Okay? So we are saying that the age is has high correlation with the charges. Not high, lah. The highest correlation value we get is between age and charges. Okay? We can also look at the diagram here, the plotting. Okay, so we can sense there is a trend here between the age and the charges here using the pay plotting. We can also use the um, pay panel. So this is a bit interesting because we have the value here and also we have the diagram here. Okay, so you can obtain this figure when you install this package Psychic. Okay, and you use the pay panel in order to plot the age, BMI, children, and charges here. Okay, so for this one, we can look at the correlation here by looking at the red dot here. If we have a circle, that means there is no correlation. But if we have ellipse, like a stretch circle here, so that means they are strongly correlated. So this can be seen also here. Okay. Okay. How do we apply the multiple linear regression? Similar to what we have done before. So we use the linear model and we put dependent variable here, independent variable here, and we have the tilde here. And this is the data that we have. Okay. So if you want to predict, we just take the model here and put it here, and we just key in the value that we have here. Okay, and we get all the value here. Okay, so how do we perform that one? So we can type either by doing this charges. We want to model the charges based on the age, children, BMI, sex, smoker, region, and this is the data that we have. Or if you're lazy to type all of them, we just type dot here. So these two are the same. Huh? Okay, so we use the linear model, and this is the name of your model. Okay. So if you look at the model that we have, so we have this. So that means additional age of 1 year, you have to pay 256 additional. If you are male, you are paying less 131. Any additional BMI that you get, you will have to pay additional 339. If you have additional children, you have 479. If you are a smoker, you have to add 23,000. Okay. If you stay in this area, northwest, southeast, southwest, you pay less. Okay, so that means um, at this moment they assume that you are staying at the northeast. Northeast. Okay, and this is the summary yang tadi tu lah. Okay, so when we look at the summary of the model here, so the residual section provide summary statistics. So this is the error that we have. Okay. Since a residual is equal to the true value minus the predicted value, the maximum error will be this, the maximum error, and suggests that the model under predicted expenses by nearly 30,000. Okay, so this is under predicted expenses. So meaning that if the actual is 60,000, but you predict to be 30,000, so the error will be 30,000. Okay. On the other hand, 50% of error fall within the first quartile and the third quartile. So meaning that 50% of them fall here. Okay. And yeah. Okay. So when we look at the coefficient just now, we say that if your p-value is less than 0.05, they are significant. So we notice that we have these three which are significant: smoker, children, BMI, and also the age. And we notice that the age here, there is no star. That means the gender has nothing to do with the the gender is not significant enough to affect the insurance value. Okay? And lastly is the adjusted R square here. So the value is 0.75. So the highest you can get is 1.0. Okay, so we know that uh, nearly 75% of the variation of the dependent variable is explained by our model. So which means that 75% of the variation of our dependent variable can be explained by using the model. So that means the higher, the better. Okay, so this is for multiple, this is for single. Okay, so are you with me? Can you type number 7? Okay. So in this slide, we have 2 tasks that you need to do. Okay, the first task will be looking at the step that we need to perform here. So we have a simple linear regression and also we have the multiple linear regression. So I will put the assignment in the Smart version 3 and also the quiz. Okay, so the quiz will be based on this slide, and also the practical of this lab of this session will be also outlined in the assignment. So what you need to do is you just follow step by step, and then you produce the output, and then you submit online. Okay. Okay. So do you have any question? Okay. We will have our next class on Monday lah. So can we meet Monday 2 p.m.? That is our Nila. Okay. So see you on Monday lah. Okay. Kalau you have question, you can ask me in the WhatsApp also. Thank you.